We have already learned about how to make a stem and leaf plot and what that looks like. Today we're going to add a layer onto that, and we're going to talk about something called a back-to-back stem and leaf plot. Back-to-back stem and leaf plots let us take two data sets and compare them against each other. It's basically what happens when you take two stem and leaf plots and you put them together. We are going to use the data set that you have in front of you. So this is some data about rainfall amounts in inches. So this was data that was collected every month for a year for Portland and for Chicago. So there's 12 pieces of data since there's 12 months in a year. We're going to use this to talk about how to make a back-and-back stem and leaf plot. You'll notice on your notes outline that you have a nice big blank space. You are going to make this graph with me. And as we go through, we are going to label the graph to give you some reminders of how to make the graph. So if we're going to make a back-to-back stem and leaf plot, just like with a regular stem and leaf plot, the first thing we need to do is make the stem. The stem in this case is going to be whatever, it needs to run from the smallest to the largest number in either data set. So we have to look at both data sets. When we look through both data sets, we can see the smallest number is the 6.5 from Portland. And you can also see that the largest number is going to be the 12 inches from Chicago. Now the nice thing about this data is it's already in order, and that was intentional to try and speed the process along a little bit. But we have talked about what you need to do if you're working with data that's not in order when you first learn to make a stem and leaf plot. So these are decimals, but that doesn't really matter. The stem and leaf plot still works the same way. So the smallest place value in here is tenths. So the tenths are going to turn into our leaves, and everything else is going to turn into our stem. So if we knock the tenths off, that means our stem needs to run from 6 to 12, the smallest to the largest piece of data in either data set. So we're going to start off making our stem just like we normally would with a stem and leaf plot. And this is where we're going to label some things that I want you to label on your graph as well. So this is the smallest number from either data set. From either data set. I forgot the A. And this is the largest number from either data set. So the way this is going to work is we're going to put two stem and leaf plots together. So we're going to start this off like a normal stem and leaf plot. Since Portland's, it doesn't matter which city you put in which place. We're going to end up with one on the left and one on the right. So it doesn't really matter which one we do which. Since we're used to putting things on the right and Portland's on the top, we're going to put Portland on the right first. So we'll start our stem and leaf plot off just like we normally do. And we're going to start putting the data in it. So 6.5 is going to be a 6 and a 5, another 6.5, and then we're just going to go through 7.1, 7.2, 7.4, 7.6, and now I've got the 8 points, so 8.3 and 8.6, 9.2, 9.5, and then we've got a 10. So that's our Portland data. Now, we wrote a label up here, so we're a little crowded for space, but normally you should put a title up here, so it would normally go right there. We should label which city is which. So that's our Portland data. And over here, we're going to put our Chicago data. So this is where we're going to get a little bit creative. So we're going to draw a line on the other side of our stem, and we're going to put another stem and leaf plot on the other side of that for our Chicago data. Now where this is going to get a little bit interesting is that since we're on the left side, the stem is now on the left side of the stem and leaf plot is going to be backwards. So the smallest number should always be closest to the stem. So it's going to look like this. 8.2 and 8.3 would look like this. 8.2 closest to the stem, and then 8.3. Now, We also talked about making a key for your stem and leaf plot. We'll get to that in a minute, but the key is really important because if you look on the left side, this looks like it should be, just reading it, that looks like a 28. But we know that because we're working on the left side, that's actually not a 2.8, it's actually an 8.2. We read it backwards. So when we're done, we're going to put a key down at the bottom that's going to tell people that. It's going to tell them that, hey, when you're pulling things off the left side, you have to switch them around when you get them out of the graph. So just be aware that you read the graph backwards. So we're going to keep going and put our data in. So Chicago also had an 8.9, and then a 9.3, a 10, 10.5, 11, 11.1, 11.5, 11.7, and then we had 2, 12.0. So those are going to go down there. So we are almost done with this. Like I said, we just need to give it a key. And since we read the two sides of the graph, the left side and the right side, different directions, we actually need to give this graph two different keys to tell people how to read both sides. So I'm going to come over here on the Portland side. And remember, we said when we learned about stem and leaf plots to pick a key, or to make a key, you can pick any number you feel like. We're just grabbing a number as an example number. So I'm going to grab 8.3. So that's going to be that part of the graph. So I'm going to borrow that to make the key. So we're going to show that it looks like an 8 and then a line and then a 3. And when we pull that out of the graph, that becomes a decimal, 8.3 inches. So people could see, okay, an 8 and a 3 means 8.3, and we're measuring in inches. Now, Chicago side, we read differently. We have to read it backwards. So we're also going to have to come over here and give the Chicago side its own key because we read it differently than the Portland side of the graph. So again, we're going to pick a number for Chicago. I'll pick the 9.3. So we're going to show what it looks like in the graph. So it looks like a 3 and then a line and then a 9. But what that equals is not 39 or 3.9. We have to flip the numbers around. So a 3 and a 9 is actually 9.3 inches. So that's why the key is really important, because somebody can look at the key and realize, oh, I need to flip the numbers around and their decimals and the units in inches. So that key is giving us a lot of important information. So that's another thing to kind of label for reminders on your graph. That would be a good idea to label in your notes. Little sloppy, sorry. You can make yours tidier if you would like. You need a key for both sides because you read them differently. Okay. But this is a finished back-to-back stem and leaf plot. Now, the nice thing about this is we've got the numbers lined up against each other. We get a pretty clear comparison of how Chicago compares to Portland. So if you look, the numbers for Portland are higher up on the graph, and the numbers for Chicago compared to Portland are lower down on the graph. Well, we know that higher up is smaller numbers and lower down is bigger numbers. So we can now see visually that Chicago in this year overall got more rainfall than Portland because of those numbers that are shifted further down the graph. So that's what a back-to-back stem and leaf plot lets you do, is it gives you a nice visual comparison of two different things that you might like to compare against each other. You need to make sure that you have your completed back-to-back stem and leaf plot in your notes along with the extra labels and reminders that we added in. And then you are going to move on and you are going to try the you try problem, which is going to let you try making your own back-to-back stem and leaf plot.